Welcome back. So today we're going to talk section 5.4, factoring quadratic expressions. Within our factoring, we're going to look at greatest common factor, or we call it GCF, and we're also looking at trinomials. So when we talk about a quadratic expression, we're looking at something that maybe in a form of x squared plus 3x plus 2, where we have our largest exponent, our highest degree, being a 2. So what does it mean to factor the GCF? What we're looking for is the largest factor, the largest number or number in variables that will divide evenly into each term. So we got to know some of our division facts for this. So let's go ahead and look at example 1 here. We have 6x squared minus 32x. So I want to look at my numbers to start with, my coefficients, 6 and 32. What number will divide evenly into 6 and 32, or divide into those evenly? So we know that 2 will divide evenly into 6 and 32, and 2 is the largest number that will divide evenly into them. As I look at my variables, I have x squared and x. We hopefully notice that we can take out an x out of them. So what does that kind of look like mathematically? If you remember way back when, we asked you to do a factor tree of 6x squared, or maybe just the 6. So the factorization of 6 is 2 times 3. Those are both prime numbers. The factorization of x squared is x times x. If I look at 32, the factorization is 2 times 2 times 2 times 2 times 2. And if I look at the x, we just have an x. So when I ask for the greatest common factor, I'm looking, well, what do we have in common? We should hopefully see that we have a 2 in common, and we have an x in common, and that gives us our 2x. Then what we're going to do is put in parentheses what we have left over, kind of the leftovers. So we have 3 and an x left over from 6x squared, or 3x, and we have 2 times 2 times 2 times 2, or 16, left over from the 32x. Notice, if we were to multiply the 2x back in, or distribute that, we would end up with what we started with. 2x times 3x gives us 6x squared, and 2x times negative 16 is negative 32x. So this is kind of we're undoing the multiplication. It's already been done previously. And that's going to be our factored form. In example 2, we have 15x squared plus 10x minus 25. Again, we look at the numbers, 15, 10, and 25. What goes into all three of those? Well, the number 5 does. I have x squared, x, and no x's here. So what's the largest number of x's I can take out? Well, I can't take out any. Since this one doesn't have an x term, I can't take any out. So in parentheses, I'm going to put what we have left over once I divide 5 into each of these terms. So I get 3x squared plus 2x minus 5. And that's going to be our factored form after we take out our GCF. Again, remember, we could take and multiply that 5 in and get us that original expression. When we factor a trinomial, remember again, factoring means to rewrite as the product of factors. So we're looking for two things that'll multiply to give us that trinomial. What I like to do with this, though, is to start with a multiplication problem, just to kind of get your juices flowing. If I ask you to multiply x minus 3 to x plus 4, we've done this in the past. So we're going to multiply the x through, distribute it through. We get x squared. Multiply the x, we get a 4x. Then we're going to distribute the negative 3 through. So we're going to get a minus 3x and then a minus 12. And then cleaning this up, we get x squared plus x minus 12. And hopefully that's not too miserable for us. But what I want to do is kind of talk about where these numbers came from and why we got them. So this x squared only came from when we multiplied these first two terms together. The negative 12 came from when I multiplied the last two terms together. And this middle term came from when I multiplied the outside two numbers and the two insides together and then added them together. That gave us our x squared plus x minus 12. So we go through that because when we factor it, we're going to undo this. So I'm going to undo this x squared. So what can I multiply to give me x squared? Well, that's my x and my x. My negative 12 was negative 3 and 4. And this x came from multiplying these outside and insides and then adding together. So I come down here to x squared minus 17x plus 72. All right, so I know my first two terms have to come from x squared. So when I multiply these two terms together, I need to get x squared. The only way we can do that is to get x into x. To get my last term, we'll make it blue here if you can see that, I don't know. We have to multiply to give us 72. I'm gonna come off to the side and think about 72. Because I know that when I multiply two numbers together to get 72, there's a few things that I can multiply together to get me 72. I can do 1 and 72. I can do negative 1 and negative 72. I can do 2 and 36. How about negative 2 and negative 36? We've got 3 and what, 24. We got negative 3 and negative 24. We could do 4. 4 is going to give us, what, 118. So we got negative 4 and negative 18. We got 7, 6, or 5 doesn't go in, 6 doesn't, 7 doesn't. We got 8 and 9, and then negative 8 and negative 9. Good heavens, look at that list. So which ones do we choose? Well, remember, if I multiply the inside two together and then the outside two together and then add them, it's got to give me negative 17. So if I multiply any of these by x, I just get the number with x. So I'm looking for two of these numbers that are going to add to give me negative 17. And it looks like the very last set is going to give that to me. So if I add 1 and 72, it gives me 73. Not going to give me what I want, negative 17. If I come down here, negative 8 plus negative 9 gives me negative 17. So I get negative 8, I get negative 9. And with all our factoring problems, we could go ahead and distribute this back out and see if we get that true answer. So x times x gives us x squared. We get x times negative 9 is negative 9x. Negative 8 times x gives us negative 8x. Adding those together gives us negative 17, and negative 8 times negative 9 gives us 72. So that's going to be our factored form. I got quite a few more here. You can see as many as we want, but on this next example, notice we have a 2 out there in the front. That makes this a little more complicated. So again, we're going to multiply these first two terms together to give us 2x squared. The only way we can break up 2x squared would be 2x and x. My 12. I can break up 12, 1 and 12, 2 and 6, 3 and 4. I can also do my negatives. Negative 1, negative 2, negative 12, negative 2, negative 6, negative 3, negative 4. So a couple of things I want to bring to your attention here and maybe reduce some of our possibilities. If we notice up here, we have a positive and a positive for our two terms. Our middle term is positive and our last term is positive. The only way that we can multiply two numbers together to get a positive is if they're both positive or both negative. Knowing that, in order to get a positive when we add, we can't add two negatives to get a positive. So we know, since this is a positive and a positive, our signs, we can get rid of that entire set of choices. So we have 1, 12, 2, 6, 3, and 4. Now this becomes kind of a guessing game. So we're going to take and plug in this 1. The 1 can go here or here, and the 12 being in the other form. So, and at this point, I don't know, so I'm just going to go ahead and try my 1 and my 12 and see what happens. So if I have 2 times 12, that gives me 24, plus 1, that gives me 25, doesn't it? So we had 24x and 1x. So I know when I add those together, I don't get 11x. So I can go and get rid of my 1 and my 12. We're going to go ahead and try another one. So we have 2 and 6, we have 3 and 4. Let's go ahead and try 3 and 4. So if I put the 4 here and the 3 here, I make my 2x times 3 gives me 6x, and then 4x, that gives me 10x. So I'm pretty close, but not quite there. I could change my 3 and my 4 as well. So I could have 2x and my x, so 3 and 4. This is where a pencil really works in kind of handy because I can erase those numbers quite quickly and not have to rewrite things. So what happens here? I have 2x and 4, I get 8x, and then 3x, 8x plus 3x gives me my 11x. So this is going to be my factored form. Again, we could distribute this out in order to get that original expression. If I come back up here, a little hint for you, 2x and 4. Notice 2x and 4, if I were to leave those as 2x plus 4 and x plus 3, I would have a GCF in this expression. Notice the original expression does not have a GCF. So I will not have a GCF in one of my factors if I don't have a GCF in my trinomial. So that's going to eliminate some of our possibilities as well as we get into this. So no GCF in an expression if we don't have a GCF in the original trinomial. So let's go ahead and look at our factored form here. And maybe we'll talk a little bit more about that GCFing up here. So 2x squared, we have 2x and we have x. 6. So again, we can have 2 and 3. We can have 1 and 6. We can have the negatives, -2, -3, -1, -6. Again, we can talk about our signs. We have a negative and a positive. So our middle term is negative and our last term is positive. Again, in order to get that positive, they both have to be positive or negative. In order to add to give us a negative, we can't take two positive numbers and add to get a negative. So I can get rid of my two positive numbers. So now I'm down to just two sets of numbers, -2, -3, or -1 and -6. So we're gonna go ahead and plug in. I know, again, I cannot put my -2 with my 2 because I have GCF. So I can plug in -3 and then a -2 here. And we're gonna see if it works. So here we get 2x times -2x gives us -4x and -3x. Adding those together gives me my -7x. So that's gonna be our answer. Yay, we found it on the first time. All right, one last one here on this page. X squared plus 10x plus 24. Again, we're going to split that x squared into x and x. 24. If you think of the factors of 24, we have 1 and 24, 2 and 12, 3 and 8, 4 and 6. And then the negatives begin positive, positive, so I know it's got to be two positive terms. Looking to add to give us a 10, we get 4 and 6. And there we go. I have one last problem here. We have x squared minus 7x minus 12. Again, we can go ahead and x and exit. We're looking at -12 now, our factors. Factors to -12 are -1 and 12, or -12 and 1. 2 and -6, or -2 and 6. 3 and -4, or -3 and 4. So we're looking now, if I replace these two terms, I need to get a -12 when I multiply, so I have those here, and -7x when I add them. If I add -1 and 11, or -12, I get 11. Here I get -11, -4, 4, -1, and +1. So there are no factors over here that I can get a -7x when I add them. And again, if you want to, you can plug those in. We get close, don't we? -3 and 4, that's 1. I guess that's kind of close to 7. So if I multiply this out, I would get just a 1x. X squared plus 4x minus 3x minus 12. So the 4 and the -3 would just give us a positive x. So that doesn't give it to us. And we could try all of these, and we could see that none of these will give us that middle term. So we say that this function or this expression is not factorable. And that's going to end our factoring for the day. Good luck.